again. Today's section 1.5, measuring angles. Very similar to the section we did last week with measuring segments. But let's talk about a few. I think a lot of you know like these terms, but just in case, an acute angle. And I'm going to start using the shorthand that means angle. Less than 90 degrees. Obtuse angle more than 90, less than 180. Right angle (90°). I'm sure it comes up later, but while I'm thinking about it, if something is a right angle, you'll see that box right there. So if it says it's right angle, then you know it's 90 degrees. If it doesn't say that it's a right angle, but it has the box, then you know it's 90 degrees. And then we have, this is kind of a new one. Kind of a weird like term, but whoa. A straight angle. It's kind of a oxymoron. 180 degrees. So it's just a line. So what it's really saying is, if you measured this in degrees, not distance, but degrees, this is 180 degrees. Okay? So you'll have some basic questions that just ask about like what kind of angles these are. Okay? Alright. The other thing that we'll get into is naming an angle, or labeling an angle rather. So you could name this angle ABC. You could name this angle CBA. So the order doesn't matter. But notice the B's in the middle. So whatever's over here at the vertices has to be in the middle. In this problem, you could name it angle B and just use one letter. Now, that's not always allowed, and I'll talk about it in a minute why. But so if I said angle, if you said, "Hey, Mr. Gowdy, angle B right there," I would know exactly what you're talking about. So if we had a picture like that, you could not use angle B because I wouldn't know, are you talking about where the number 1 is or where the number 2 is? Or are you talking about the whole thing? Like, it's not clear what you're talking about. So if I wanted to label the whole thing, I would have to say angle ABD. Okay, so you could ABC, CBD, like, you know, the letter combinations, but notice that B is always in the middle, and that's because it's right here on what we call the vertices. Okay, So we talked about that word congruent. And really, I think the easiest way to understand when do we say congruent and when do we say equal, I talked about the other day, is if you know the number that goes, like the actual degrees in this case, then you can say that they are equal. If you don't know the number, then they can be congruent. It just means, hey, they have the same size. They're the same size. Okay, so another way of knowing that they're congruent is this little arch in the angle. So on segments, if segments were congruent, we had that little slash mark on the segments. If angles are congruent, we have the little arc symbol. So we could say that angle ABC is congruent to angle DEF. And if you did know, if you were told, hey, they're congruent and one of them was 60 degrees, then you could say, well, then the other one's 60 degrees. So remember that equal and congruent we do sometimes use kind of interchangeably. So you'll have a couple where they're labeled congruent and they just want to know what's the other one. So should be fairly straightforward. All right, now just like the other day with segment, we have angle addition postulate. And it's the same as the segment addition, it just uses angles. So, I mean, same concept. Sometimes there's points on the lines, sometimes there's not. But so if they use an uppercase letter again, you can just assume that's a point. So segment addition, and it's actually written like this: measure of angle ABC plus the measure of angle CBD equals the measure of angle ABD. So that little m means measure, means the actual number. Because I can add numbers together, I can't add a shape to another shape and come up with some value. Okay, so the problems when you get to angle addition, which most of the problems today are dealing with angle addition, some of them are very simple, where it could just be this one is 54 degrees and that one's 87 degrees. What's the whole thing? Or it might tell you the whole thing and then one of the other ones is, 83, whatever. Then you subtract. Okay? Excuse me. So I did talk about, the other day that a lot of geometry is that we start with a geometry kind of concept and then we use algebra. So if it said, give me some letters. That angle ABD equaled 145 degrees. And then it may ask you to find something. So let's just say it says find angle ABC. So we'd have to say, well, I know each part is these algebra things, and the whole thing is 145. So if I plug it into basically the segment addition, I can do 2x plus 10 plus 4x minus 3 equals 145, and then I can solve it. So combining that 2x and the 4x, 6x, 10 minus 3 is 7. Subtract 7. Is that going to be 8? Oh, that's not right. 138. And divide by 6. So be careful, because a lot of people go, oh, I set up this equation, I solved it, I got 23, fantastic. Not fantastic, because the question said find ABC. It didn't say solve for X. So I need to keep going. So the ABC part is 2x plus 10. So I need to plug in the 23. So angle ABC is 56 degrees. So make sure you answer the question. That way you don't do all the correct work and then you don't get the payoff of getting the right answer. Okay, so like I said, most of your problems today are going to deal with segment addition. Some of them using numbers, some of them using letters, or excuse me, like variables, 2x minus, plus 10, stuff like that. Okay, remember, like, to use angle addition, you're going to have to know something about each part and the whole thing. So if you have a straight angle is 180 degrees. So if you don't know anything about, like the whole thing, but it's a straight line, then you can conclude that the whole thing is 180. Okay? All right, and then one other small item that we talked about already with segments, this word bisect. And I think the easiest thing a bisect means cut in half. Or we're going to have equal parts. So if we had this one, very simply, let's say that's 30 degrees. And if it said that BD bisects angle ABC, then you can automatically, remember it cuts it in half or it's in equal parts, you can conclude that's going to be 30. Okay, if draw a little bit bigger. You had it with variables, 3x plus 6, 7x minus 18, and it said the same thing, that BD bisects. Then because it bisects, you don't know the whole thing is however many degrees it is, 70 degrees or whatever. But if it bisects, it cuts it in half or it's equal parts. So you could, this is the exception to kind of knowing something about the whole thing. You know they're equal parts, so I can do this equals this. Okay, so if I subtract the 3x over and then add 18, and I get x equals 6. And then again, be careful that you answer the question. So it could just say solve for x. It could ask for what's angle ABD, or what's angle DBC, or what's angle ABC. You're going to have to plug it in to whatever part or parts you need to do. Unless it says solve for x. And if it does, then you did that. So just make sure again, let me glance at the paper. Yeah, it doesn't ask for x on very many of them. It wants to know what are all the angles, what is this one angle. So you're going to have to plug it in. Okay, so this section is, in my opinion, like if you understood section number 2, which was measuring segments, then this one is the exact same thing, just angles instead of segments. But angle addition postulate is another one that will come up down the road. So segment addition and angle addition are two of the big things that carry forward. Alrighty. So again, just go back to the Canvas for the actual assignment. Make sure, especially on these ones, I need to see your work. Okay? Alright. So knock it out tonight, guys. Shouldn't be a big deal, like I said, if you understood the other part. And we will see you again tomorrow. Have a great night.